Hello, James Flaten here. I'd like to talk a little bit about OpenRocket, and in this particular case, I'd like to try OpenRocket totally from scratch to build a rocket without any model already existing. So let me share my screen and open OpenRocket. This happens to be version 24.12, which is a little bit different in the way the menus work from the previous versions. Okay, so when you first open OpenRocket, there is nothing on the screen. You can open a model if one exists, but in this particular case, I'm interested in just drawing a rocket completely from scratch. So I guess the first thing I need a concept. So my plan is to basically build a 4-inch diameter rocket, mostly out of blue tube, one of my favorite materials to build out of. And let's get started first with a nose cone. So this particular version of OpenRocket actually encourages me to choose a nose cone from a parts library, which is fine. If you're going to 3D print your nose cone, you might not want to do this, but in fact, I almost always built rockets with commercial nose cones. So I'm going to click here to get the nose cones sorted from smallest to largest, and click here to get them sorted from largest to smallest, and then just scroll down until I can find a 4-inch, basically close to 4-inch diameter nose cone. And here's one. So here's a Lock Precision nose cone, polypropylene nose cone. And I will choose it. So when I say close, it will have drawn that nose cone. And presumably the information about this nose cone, which is drawn from a library, is accurate. One could go back and tweak these numbers if necessary, but I'll just accept this. So here's my nose cone. And as is typical for nose cones, it has a pointy shape. This happens to be an ogive nose cone. And it has a shoulder, so it fits into an airframe, but there's no airframe here yet. And it's unstable. I can see the stability. I'm going to keep my eye on this number all the time. And right now it's negative 0.5. That basically means that this particular piece of a rocket is fundamentally unstable. I need something to trail it, an airframe, frankly, to get the stability under control. Okay, so after my nose cone, I want a body tube. In fact, I'm going to make a dual deploy rocket, so I'll have two body tubes, the upper body tube, the lower body tube. And again, it's kind of guessing that I'm interested in choosing a body tube. Let me actually sort this by manufacturer. And here is, in fact, Always Ready Rocketry. That's the company that sells Blue Tube. And there it is. There is a what they call a 4-inch or 3.9-inch diameter airframe. Could be also a motor mount. And so I will accept that. And it comes in 48-inch long sections. I don't need it to be that big. So I'm just going to eyeball this and just make it shorter until it looks sort of reasonable. That's perhaps about as long as I want my upper airframe section to be. I'm going to click automatic. What that means is it's going to try hard when I add extra parts to make them fit the existing parts. And I'm a little surprised that this says vulcanized rubber. And the reason is, it turns out that Blue Tube is in the library. Okay, and so I can actually choose Blue Tube and it changes the density just a little tiny bit. I might not bother doing that every single time, but it is possible. Okay, so now I have two parts. My stability is still not healthy, but I'm not finished yet. I want a coupler tube, and the coupler tube is going to connect this particular body tube to the one below it. So let me say coupler tube next, tube coupler. And basically I want a coupler tube. It would be a 4-inch coupler tube. There it is, 8 inches long. That's good. That means it sticks into the section above it and the section below it by 4 inches each, one diameter. That's good. And here's one thing I noticed. It drew the coupler tube fully inside of the body tube, and I actually want it to stick out. So I'm going to just shift it down by 4 inches. So now it's half in the current body tube, and it's going to be half in the body tube below. And I'm going to click automatic to keep things lined up with each other. And I'm not even going to bother changing it to Bluetooth, but you know how to do that. Okay. The next thing I want is I want another body tube. And so this is the body tube below. And it's kind of guessing that I probably want some more 4-inch blue tube, so that's true. And I don't, in fact, want it to be that long. So I'm just sort of eyeballing this. What kind of looks good? I'm not even looking at the numbers. I'm literally looking only at the picture. And sure, there's about the length of a reasonable rocket. Let me say automatic. Let me say okay. Now what else do I need? Well, I need fins. I need a motor mount tube. I need centering rings. Let's start with the motor mount tube. Okay, so if I am clicking on the lower body tube, and then I can say that I want an inner tube inside of the lower body tube. And it's trying to guess what I'm interested in. And it turns out it's sticking all these blue tube things up top because I seem to be interested in blue tube. And indeed, I'm going to choose a 54 millimeter diameter motor mount tube. It comes in 48-inch sections, and I don't need it to be that long. Let's say that I want this to be maybe 12 inches long. And so there it is, a 54 millimeter diameter motor mount tube. Here's one more thing I should do, though. Double click on it, click on motor, and tell it this is a motor mount tube. Eventually, when I choose a motor, it's going to say, which tube do you want to be your motor mount tube? Here's where I can tell it, and then I won't have to guess later on. I want some centering rings to hold that motor mount tube in place. So the centering rings actually will be attached to the body tube. And so here we go, centering rings. In this case, I'm actually not going to choose a centering ring from a library. I'm going to make it myself. And the reason is this is what I usually do. I make my centering rings from birch plywood. I almost always use 1/4-inch thick plywood. And this is currently drawn here at the very base. I'm going to move it up by about 1/4 inch. And the reason is I kind of like that didn't do quite what I wanted. Let me move it up by 1/2 inch. Okay. Oops, that's also not what I wanted. Minus 1/4 inch. That's better. I like my lowest centering ring to be slightly inside of the airframe so that I can get some epoxy underneath it, get a fillet underneath it as well as a fillet above it. If I were to duplicate that, so now I have 2 of them, and I could label them forward centering ring, aft centering ring. I think I won't bother. And let me edit this one and just move it wrong direction, move it up to there it is, close to the top of my motor mount tube, made of birch, 1/4 inch thick. Okay. I need some fins. So the fins would also be part of the lower body tube. And so let me go find fins. Let me choose trapezoidal fins. And here they are. They're very weeny. Let me say that I want 4 fins, not 3. Let me say that I want the fins. Notice that right now my stability is minus 2.97, so the fins are not nearly big enough. So let me just say my fin height will be maybe 3 inches tall. And maybe they will be 10 inches long at the root. And let's say maybe they will be 6 inches long at the top. And let me increase the sweep angle here to be 4 inches. And that looks very boring. Let me try 3 inches. Fair enough. Okay, so nothing fancy. My stability is up to 1.67. That sounds more promising. In fact, I'm going to intentionally make a little bit of a mistake here. I'm going to say that my height is only 2 inches. And so, nope, that was much too small. Height 2.5 inches. Height 2.75 inches. There we go. Okay, I've got a stability of 1.3. And the reason I think this is a mistake is once I put a motor in it, I bet my stability will go sour. But here's a couple things. One thing is I noticed that my fins are overlapping my lower centering ring. So let me just move my fin up a little bit. Wrong direction. Okay, so now the fins are at least in between the centering rings. And let me add fin tabs. So I clicked on fin tabs and let me say automatic. And what it will do is it will assume the fin tabs go from the front of the fin down to the motor mount tube and from the back of the fin down to the motor mount tube as if there are slots in the airframe. Very good. And let's say that I'm making my fins, definitely not out of balsa. That would be disastrous. Let's say that I'm making my fins out of fiberglass. And let's say my fins are maybe 1/8 inch thick fiberglass, 0.125 inches thick. And here is where you could put information about epoxy and fillets and things like that. I'm not going to bother, but that's where you would put it. Interestingly enough, I lost a little bit of ground in my stability by making these things out of, oh yes, and the reason is fiberglass fins are heavier than balsa fins. Okay, so I do have to get my height back up here a little bit at least. Just trying to get my stability to be somewhat reasonable. Okay, so there it is. My stability now is 1.15. I'm trying to get it to be above 1. Okay. So, you like it? I don't really like it. Those fins look awfully large, but anyway, at least the numbers are working out, so I think I will leave it alone. Let me add a few more pieces before I bother putting a motor in. I want some bulk plates on either end of my coupler tube because I'm going to put avionics inside of the coupler tube. So if I click on the tube coupler and say that I want a bulk head, and I will say that this is going to be made not out of cardboard, but out of wood. Plywood, 0.25 inches. Fine, so there's one bulkhead. If I duplicate that, and then take the second one, and I can put it on the other end. Okay, so now I have bulkheads on either end of my av bay. Let's say that inside of my av bay, I'm going to put some avionics. So I'm going to click on a mass component, and I'm going to call the mass component avionics. And I'm going to say, this is a bug. Basically, every time that I add some weight, it forgets what I named the component. But if I add the weight or the mass, the weight actually 8 ounces, and then I name it avionics, it will remember, I think. Yes. So there's avionics. That's not the right place for it, though. Let me just say that my avionics are approximately in the middle of, that would be fine, maybe 3.5 inches in the middle of the nav bay. Let me also add at the base of the nose cone a mass component, which would be a forged eye bolt, which is 1 ounce, approximately the one that I use, forged eye bolt. And that, of course, is not where it's going to be located. It's going to be located at the base of the nose cone. That's what I'm going to attach my shock cord to. And then, oh, I forgot what it was called, so I'll try that again, forged eye bolt. And then let me duplicate that and bring a forged eye bolt down into the tube coupler area. And stick it right on that end of the avionics bay. And let me make another one. And stick this one right on this end of the avionics bay. And a fourth one, duplicate. This one now is going to be down here with the lower body tube. And this one is going to be attached to the upper centering ring. So it looks like it's about 17.75 inches. That's a good place for it. Just for fun, let me actually change its radial location to maybe about 1.5 inches. So that's kind of a more realistic location for it. And then I need a parachute. So in the lower body tube, I'm going to put a drogue parachute. And so it's offering me a bunch of parachute options. Let me just scroll down here and find an 18-inch parachute for my drogue parachute, maybe one from Public Missiles. How about this one right here? Okay, so a Public Missiles 18-inch parachute. And let's say that that packs to, if it's 4 inches wide, it maybe is 2 inches long. That could be excessive. And let me just put that at the bottom of the drogue area. And for the moment, I'm not going to tell it when to deploy, just for now. A little bit too low. There we go. And while I'm down here, let me add some shock cord. Let me go into feet, and let me say that I want 15 feet of shock cord, and let me say my shock cord is going to be made out of tubular nylon 14 millimeter. Let's say that this packs to 4 inches wide and maybe 3 inches long. And I just want to put that down on top of the parachute. And it's overlapping the parachute a little bit. So there we go. Now for the upper section, I want a parachute up there too. Offers me lots of parachutes. Let's say that I might need a 48-inch diameter parachute for this size of a rocket. I'm guessing here, we'll see what our landing speed ends up to be. Again, I'm not going to tell it when to eject the parachute yet. And I'm going to say that this parachute packs to 4 inches by 4 inches. And I'm going to put it down right on top of that eye bolt. Good. And then let me just say I need some more shock cord. So if I just duplicate this shock cord, and I can bring this shock cord up into this section and edit it and just move it. And so it's a more reasonable location, like right above the parachute. Good. So it looks like there's plenty of space in the drogue section. There's probably adequate space in the main section for the parachute and the shock cord if I'm being reasonable about my sizes here. And I have 1.97 for my stability. Let's find out what happens when I put a motor in it. So I click on motor configurations. It knows that the inner tube is the motor mount tube. And I say new configuration. And it gives me essentially all the Cicerone motors. I could get all the Cicerone Aerotech motors. I could get all the Cicerone Aerotech Animal Works motors. Let me just stick with Aerotech, stick with Cicerone motors. And I don't need to limit my motor to the length of my motor mount tube. On the other hand, I do need to limit my motor to motors that will fit in this motor mount tube. So limit it to 2.1 inches. So that changes to all Cicerone motors. That's the only ones I have selected. Yep. All Cicerone motors that are 54 millimeter diameter or smaller. In fact, I just want only the 54 millimeter ones. And so I'm going to drag the smallest diameter right up to be the same as the largest diameter. And there's the full list. These are all Cicerone technology motors that are 54 millimeters, apparently. There's a bunch of 1 grains. There's a bunch of 2 grains. And so let me just choose one. Let me choose the, how about this one, the J240 motor. Okay, and it's 16 seconds of adjustable delay. That's good. And so here's a couple things that are going to happen when I say okay. First of all, it's going to draw the motor here. And second of all, it's going to update the stability. And since I'm getting extra weight in the tail of the rocket, I'm going to lose ground on stability. Let's find out how much. Right now, my stability is 1.97. Boom. My stability now is 0.895. Even less than 1. I'm a little uncomfortable with that. So to bring the stability back above 1, maybe even up to about 1.5, I'm going to add a little bit of ballast into the nose cone. So here we go, back to the nose cone, another mass component. And let me watch my stability, 0.895, 1 ounce. It's about 0.989, 2 ounces, 108, 3 ounces, 4 ounces, 5 ounces, 6 ounces. On the other hand, that's a slightly unrealistic location for this ballast. So I need to move the ballast into the nose cone. This is about where it really would be. Let's say that the ballast is going to be maybe 2 inches by 2 inches. And so I'm okay with that. And I'm at 1.39. Let me increase the ballast to 8 ounces. I'm at 1.55. I'm happy with that. Okay. So now I have a motor. I have a rocket with the motor in place that is a reasonable stability at 1.55. I could have gotten away with a bit less, I suppose. Let me look at flight simulations. So in this particular version of OpenRocket, well, it's throwing errors because it's already tried to do a simulation, even though I haven't asked for it to do one yet. If I click on New Simulation, it will draw a new line. It will tell me what are my details here. And so one thing I see is sort of modest wind speeds. I'm happy with that for now. I see that I have already, with this version of OpenRocket, memorized the location of the North Branch launch site, which is just outside of the Twin Cities here in Minnesota. And they use 96-inch long rails. So it already remembers that. Now, this version of OpenRocket, oddly enough, does not have a plot on this screen. I'm used to seeing plot right down here, and it doesn't have that. So I just have to check my details here, say OK. And then I have to say plot here. And I want to add, besides altitude, velocity, and acceleration, I want to add drift. So I'm going to add drift here as lateral distance. So I'm going to plot 4 things. And now I say plot. And this is bad. First of all, it's not dual deploy, and that's because I never told it where the parachutes are going to come out. So I will fix that. On the other hand, I also noticed that it's throwing errors at me. And if I double click on this error message, it says, recovery device was deployed at high speed, 158 feet per second. In fact, it says that for both of the parachutes. So right there, that's a bad number. What actually happened here is that the parachutes deployed while the thing was still going up, still pretty fast, in fact. So I need to fix that. So let me go and find this parachute, edit it. This is my drogue parachute, and say, I want this parachute to come out at apogee. And then here's my other parachute. This is my main parachute, and I want this one to come out at a specific altitude during descent. How about I try 500 feet? Okay. Now if I go and try a new simulation, those are all the right parameters. And then I can plot it. And interesting. First of all, I see that it goes up to about 3,300 feet. And then it pulls a parachute here, and then it comes down slower under 2 parachutes. On the other hand, it's still throwing an error. Let's see what that error is. Got it. Okay, so it's complaining that one of the parachutes, the second one in particular, was deployed at what it's considering high speed, 66 feet per second. I know what's going on. Let me just talk through this. First of all, it's coming off the rod at 58.5 feet per second. I'm okay with that. I want that to be 45 feet per second or faster. It's getting to 3,300 feet. Before it was only getting to 3,000 feet. That's because it was pulling out parachutes on the way up. So now the parachutes at least are coming out at the top. This is the deployment speed for the landing parachute. The apogee parachute comes out when it's not really moving at all, but the main parachute comes out when it's falling at this speed under the drogue parachute. And so, in fact, it's moving at this rate under drogue parachute, and then it pulls the main parachute, and OpenRocket is not totally sure that that's a good idea, but in fact, that will be fine. Optimum delay is 10.7 seconds coast time. That's good because I have 16 seconds of delay grain available to me, so I can grind that down to about 10 or 11 seconds. And then hit the ground velocity, 23.9 feet per second. I'm actually happy with that. Basically, that means that I guessed right. A 48-inch diameter main parachute coupled with a much smaller drogue parachute would be appropriate to get this thing to land. I like to land things between 20 and 25 feet per second. Technically, you can land things, the rules say up to 35 feet per second. It's very risky to go that fast. Okay, so there it is from scratch. I fiddled around with adding ballast to get my stability a little higher. If I didn't have so much ballast, I would have lower stability, but perhaps I would go to slightly higher altitude. Frankly, I still think these fins look kind of clunky and oversized. So if it were me, and if I were really going to build something, I would probably try to make it look slightly cooler than this. But keep my eyes definitely on the stability for every change I make. Okay, that's all I got for OpenRocket from scratch.